Hi everyone, my name is Whitney Griffith and today I'll be presenting to you my thoughts on architecting production ready blockchain apps from the experience that I've had at Microsoft so far. So who am I exactly? I am a software engineer at Microsoft. I work on a team called Commercial Software Engineers, where we work alongside our top 500 customers, who are oftentimes Fortune 100 customers spread across the world, to architect and implement production-ready solutions across different work streams such as blockchain, big data, machine learning, and also attached to different industries such as healthcare, manufacturing, retail, fintech, and any industry that Microsoft deems need technical transformation in the future. So with that said, myself alongside one other person, David Burello, is the only two blockchain technical leads on my organization of roughly 800, 900 developers across the world. And since starting at Microsoft last March, I worked on two production-ready blockchain enterprise solutions based in Japan, and this is what I'll be presenting today. So how my team operates is the fact that we have top customers who have multi-year contracts with Microsoft to spend millions of dollars in Azure credits. And oftentimes these are tech-first companies. For instance, if we look at Amazon, who is also a retail company, but they are tech-first. So therefore, Amazon understands scale and crunching code as quickly as possible. But when we look at Walmart or the Krogers of the world, they aren't tech-first. They are coming from a traditional background of regular business, now realizing the need for technology and innovation. So oftentimes these type of companies need hand-holding to like really figure out how to leverage technology and innovation to help them stay on top of their industry. So the first thing myself and my team does is we enter into an architectural design session with our customer who came to us with a request. And in this session, the point of it is for us to capture what exactly they want to do, where they are so far, and like what exactly is our success metric for what we are going to build in roughly 3 to 6 months. So in the blockchain engagements that I've been in, we realize at this phase in architectural design session that there's a lot of common mistakes being brought to the table in companies who want to adopt blockchain. So for instance, the first one is often there's one big company, one giant that is like, yeah, it's cool for, let's create a blockchain, and maybe the small companies we interact, we can invite them into the blockchain alongside us. And but in their mind, they're still thinking full control. So it's like they're creating it and then they're inviting these external companies, and then those external companies are limited to what they can do within this decentralized permission world. And that is definitely not what we want, because as we know, blockchain is all around removing that centralized control and enabling common goals and logic. Another big mistake is we see that oftentimes the blockchain going along the same lines of the control thinking, usually what architecture end up being is a blockchain that is acting as a really slow database, because that company, that big company, that giant company does whatever they can to control who can come in and out of the blockchain and so forth. So overall, that largest company wants a bit of centralized flow, and I have a pretty nice diagram that shows that, where this is the traditional structure of architecture before blockchain became prominent, where we have this firewall, there's this big company that has like some website, and all of their smaller companies they interact has to go through this website before actually interacting with the logic. And behind this website is the company's database. But now when they're trying to adopt blockchain in this control manner, all they're doing is really swapping out that database for blockchain. And honestly, at this point, there's no benefits in the blockchain, and it just becomes a really slow transactional database. And we know how hard it is to scale blockchain already. So what we have to do in this session is educate. So before we even start speaking of technology and like the solution, we fixate on the concept behind blockchain, where we shoot for blockchain first, where the blockchain is the source of truth in terms of events and different smart contract logic that needs to consistently persist to ensure that this ecosystem we are creating stays in compliant. Another part we have to understand is the fact that there's more than one company or more than one party involved in this process. So let's say it's one company building a blockchain solution for a lot of their target customers. The whole point is there's that one company, and then each target customer is an individual representative on the blockchain, right? And because in understanding that, every single person, the company, person A or company B, comes to the blockchain system or the ecosystem you create around the blockchain with their own external systems in place. So for instance, a company will come to this ecosystem with other databases and like maybe other websites or maybe their mobile app, and this have to be integrated to the blockchain. Same with the customer. Let's say user A comes to the blockchain with their own identity, whether it's a decentralized identity, ideally a decentralized identity, as well as whatever device they're using to connect to your ecosystem, and what is the constraints of their situation and context. Another big part of it is that once we are ideating, and before we actually decide putting pen and paper on like what exactly we're going to build, we want to ensure that all companies and target parties are represented in some form at the brainstorming phase. So for instance, if this ecosystem we are creating around blockchain involves 5 different companies, representatives of those 5 different companies have to be at the table to ensure that every company raise their opinions and their needs and their hard nose and actively contribute to the development process, because it is very important that everyone is represented in this ecosystem. Because as we know, once we create an ecosystem, once we launch an application in the blockchain world, everything is pretty much permanently written. So if we don't have all these parties represented, we will end up in a situation where we will have created our state of the world and expect others to fit in when they can't really fit in because we didn't take them into account. And with that said, this is where we actively practice 2 designs. We do user-centered design, where this is literally being aware of the context in which your user, your target user, exists in before even taking the action of signing into your end solution. So a good example in the fintech world is what exactly are the on and off ramps for the banking systems for your target user in Kenya, let's say. Another design practice we use is domain-driven design, where in technology is literally just a tool that integrates with real-world systems, real-world logic, real-world industries to be able to empower those logic, those processes, those flows. So with that said, if you're a blockchain expert, you may not necessarily be an expert in the industry you're building for. If you're a blockchain founder, you may understand startup mechanics, you may understand design thinking, you may understand like problem solving, you may understand how to code, but you may not actually understand and have the experience in the industry you're building for. So therefore, this is where domain-driven design comes in, which is literally a deep integration between the design, the software engineering, and the industry/domain experts from the very beginning. So in my situation, when in 2018, when I attempted to solve for the money transfer situation between the Caribbean and the US, one of my biggest problems and my biggest mistakes is the fact that it took me 6 months before accepting that I am not a fintech expert. I literally have no understanding of how finance and money flows across, like just outside of technology and outside of the blockchain context. I didn't know that. And if I accepted that from the very beginning, I would have known how to strategically build my team to fill those gaps and therefore facilitate true domain-driven design so that the end solution could be discussed and decided on before actually implementing and so forth. So moving on, my presentation and the work that I do at Microsoft is around, one second, is around enterprise blockchain development. And what enterprise blockchain development means in our context is pretty much we are creating permission blockchain where the companies create their own instance of a quorum blockchain, which is pretty much an Ethereum blockchain built in design, built in intentionality for like built in consortium management and so forth. So with that said, we are still working in the Ethereum world, but we are understanding that every member within our blockchain system, we know who they are. We have KYC in place, as well as we have different governing rules that governs why they're here and what they have to do to remain here and what will happen if they leave. So with that said, we are bringing multiple enterprises and multiple companies to the table to be able to develop this permissioned blockchain consortium. And we asked ourselves oftentimes why or when is it really valuable to leverage blockchain in this situation. So based on just simple common sense, as well as based on understanding when exactly it is valuable to put that big heavy blockchain behind a solution versus using a faster database, we realized the following. One main reason, or the only reason, to have a blockchain in place is we have to have a common goal among the companies, among company A and all the target users. And in the company perspective, those common goals are usually either to optimize of existing process that company A and company B shares, or maybe to create a unified user platform to benefit the users of both company A and company B. Maybe company A and company B already share a user base, or maybe they believe that it could be a good business investment to create this end platform to be able to grow their user base even further and benefit collectively. But once again, as I mentioned before, we have to understand that company and company B are coming into this world with their unique data policies, their unique reporting needs, their unique development styles, and pretty much their own unique individual external systems that now have to make sense and interact with the blockchain world. So this is a diagram around the permission network where, as you see, we create our own blockchain instance. In this situation, we have 3 members within our permission blockchain, and each member pretty much hosts their own node. And on each side or across each node, you can see that everyone has their own blockchain system, or sorry, their own external systems, such as a server, database, their computers, and so forth. And the way how we design our enterprise blockchain solutions is we stay in the Ethereum world because we envision eventually moving to the public networks or doing some form of bridge when it becomes viable, once the technology becomes viable for that. But as of now, it makes sense for us to stay in the permission world due to like the unique data needs versus like flooding the public blockchain with like minimal transactional data that is only relevant to these 3 companies. So this is a high-level architecture of the BTB approach, where is within our permission blockchain, we are literally within our overall enterprise blockchain solution, we are designing for businesses to share a common goal, where the 3 nodes, as I mentioned, is 3 unique companies, and these icons are representative of external systems in the Azure/Microsoft world, where this icon is a representative of a serverless function. This is a web UI/web API, or even like your mobile apps that you want to develop. These are logic apps, where it's pretty much similar to serverless microservices. And of course, maybe you'll have like a business intelligence dashboard, a SQL database, and so on. And even like pretty much anything that your business needs to run outside of this blockchain world. And then of course, the B2C approach is building it one business or multiple businesses for multiple end users, where once again, we have the blockchain, we have a nodes representing the companies, and then we have the showing of the user entering this blockchain ecosystem via their public-private key or decentralized identity, wherever they're accessing it from their devices. So let's dive into some real-world examples of the architectures we have implemented. So I spoke briefly about it, but a lot of these architectures have been powered by Azure Services. So the first one is Azure Functions, which is pretty much, like I said, a serverless microservice hosted in the Azure cloud and can be written in any language you deem worthy, for instance, JavaScript, .NET, Python. Logic Apps is pretty much an Azure function, but versus writing it in code, you actually can drag and drop. So it's codeless and it's pretty easy. In fact, a good bit of my work has been around the Logic Apps, and this Logic App is very powerful in the scaling of the ecosystem around blockchain. For instance, if I'm building React apps or just a basic web app, we often ask ourselves, how do we connect to the smart contract in the public Ethereum or our private blockchain? These Logic Apps enable that very seamlessly. So does the Azure Functions, but of course you have to code to enable that. And then Event Grid is pretty much an enterprise pub and sub of events between microservices. So for instance, if we had one microservice doing A, the moment that first microservice is finished doing A, it publishes some sort of event to the entire ecosystem saying this was done, and whoever is interested in that type of message will actually receive it. So those are the three Azure services that really was pivotal in building these solutions. And this is a couple of screenshots of what a Logic app looks like, especially when connecting to Ethereum smart contracts. So once you're in the Azure portal, you pretty much create a Logic app, a new instance of a Logic app. And as you notice, we have two concepts here. We have triggers and then we have actions, where a trigger is pretty much what you define will trigger this Logic app to execute. So for instance, a smart contract in the blockchain in which you're connected to actually emitting an event. So that is a valuable trigger, and you want your Logic app to listen to those events and therefore respond, where your action is the response, where it could either be deploy a new smart contract or execute a specific smart contract function, or maybe just query the state of that smart contract. So that is one example of the Logic app. And this is another screenshot that shows two variant flows based on you sending the HTTP request to this Logic app, simple API UI, client to API architecture, where your client is your mobile app or your web app. And therefore, once your customer or your user makes an action in your app, it will send an API request based on that action. And therefore, this Logic apps is sitting there waiting on that API request. And once it's received, it is able to either query the smart contract in this specific example or execute the smart contract in this specific example. And when that is done, it is able to send the response back to your client, which is your mobile app or web app. And then the other type, so this was the HTTP request listener. We also have an event listener, where this goes back to the event grid that I showed. And of course, that's Azure context, but in any cloud, any solution you're using for hosting should have some level of events management. And this Logic app is triggered when a certain event occurs within your smart contract. So for instance, if you have written smart contracts, you know you can emit events. So when that event is emitted, this Logic app is sitting there listening for that specific event. And once it's done, you can do multiple things. For instance, insert a row in the SQL database that you have external to the blockchain based on whatever information that came through from that event. Or maybe you can just publish to Event Grid so that your other microservices that you created could be able to act on it. So let's get into consortium governance for a bit. This is specific to the enterprise world. or any type of partnership you're creating among multiple companies, where in our case, once I said we're using permission blockchain, which is in this situation Ethereum Quorum hosted in Azure. And because of the fact that we're using Azure blockchain service to manage our blockchain, our instance of our own blockchain, Azure provides us with like simple network deployment on operations, as well as built-in consortium management, where you're easily able to create rules and logic around the addition of new members, the removal of members, what that member is able to do in regards to changing the state of the blockchain, and so forth. And then another part of this is the concept of development. When you're actively developing your blockchain solution, or let's say your solution is already in the market, but of course you have iterations and the release of multiple versions, then you have a concept of continuous integration and continuous deployment, where you're constantly making changes either to the smart contract or to your application code and so forth. So this is where the Azure DevOps comes in, where Azure DevOps is able to manage exactly from a governance perspective, who is able to approve new pull requests and new releases. For instance, let's say I am working in company A and there's other developers working in company B. Can I just push a change to production to change the state of the blockchain as well as the end product? Or do we have to go through a certain approval where we require one member of a certain privilege from each company to approve before this change to the blockchain state occurs? So that's where this comes in, as well as the fact that we know that even if we're using permission or permissionless blockchain, we know that once we deploy a smart contract, that smart contract cannot be deleted. And the way that we reference a smart contract is through ABI, which is equivalent to a URL on the web. For instance, when you go to www.microsoft.com, that's sort of like a pointer to that Microsoft page. The ABI is a pointer to your smart contract. So as I mentioned, in our Logic apps and our Azure functions, or maybe just in your React code, you are having to connect to a smart contract using that ABI. So in Azure DevOps, you're able to seamlessly update that on every PR that you're writing a new smart contract and deploying a new smart contract for. So for instance, let's say you have a smart contract for minting of coin, right? And that minting of coin smart contract is already in the blockchain world, well, within the blockchain ecosystem. And then let's say this week we realize we had a bug and we want to push that a change to fix that bug, right? We can't do anything in regards to removing the first edition of that mint coin, but what we can do is deploy a new version of that mint coin and update all of our references to that specific smart contract address across our entire solution to point to that newly updated ABI, aka URL. And of course, Azure DevOps also enable us to maintain one canonical blockchain state that ensures that everyone within this ecosystem, even including your users, can trust that this blockchain state has not been tampered with or hasn't been, like for instance, going back to the example of full control, one company wanted full control. This ensures that one company isn't taking advantage of the blockchain world. So I'm going to dive into a fintech custom example that I did in Japan, where this was a part of a larger mobility as a service project, where our goal, and for some further context, in Japan, there's roughly 8,000 plus different train providers, bus providers, taxi providers, and just so many different operators for transport around Japan. So from a user perspective, whether it's a tourist or just a typical Japanese living in Japan, when you're trying to get from point A to point C, they might have to jump like 2 different trains, a train on a bus and so forth. And because these train companies and bus companies are completely different, the user is forced to buy multiple tickets or have multiple like metro cards and load those in order to be able to enter these different like systems, these different company systems. So obviously this is very restrictive, and a user really doesn't care, the end user really doesn't care who owns what bus and who owns what train. So therefore, the transport industry in Japan, in fact, this was a mandate from the government, came together and said that transport industry, please centralize and figure out a way to unify your offerings so that our end users or the people that need transport does not have to go through a lot of struggle to be able to really get from point A to point B. So with that said, like I mentioned, this reason for coming together was a common goal to create a unified user platform for their shared users and still sharing the profit. So from a project perspective, from a development perspective, and a problem solving perspective, we knew that we needed to create a solution where a user, an average user, is able to get from point A to point B using one ticket, even though they're using multiple services. So from a blockchain perspective, that meant that we needed one ticket that is of the ERC 721 standard, that is expressing all the multiple tickets and jumps that user will have to do. And all that user will do is show that ticket or scan that ticket, and will be able to enter all of the different systems. And some example services that was a part of this ecosystem was the financial services. For instance, we had one of the largest banks in Japan step up to join this consortium to be able to be that on and off ramp for Japanese yen to ERC20 tokens. And then we have like the automotive companies, for instance, the ones who provide taxis and even car rentals or ride sharing apps, as well as we had retail companies. And this goes to the mobility as a service flow, where it's all around like how could you seamlessly get all the things you need in life with just one flow. So for instance, if I'm calling a ride from my office to my house and I know I have to stop by Walmart to get groceries, I can effectively do all of this in the app, and all the driver of my Uber has to do is pull up in front of Walmart, pick up my groceries, and we can continue on our route. So that's where the retail company came in. And then we have, of course, trains and buses, and then insurance. If you don't know, Japan is pretty strict on punctuality. In fact, it's very rare for a train to run late. And because of this, the insurance companies have a big market where in our solution, if someone is really time constrained and books a ticket specifically to get from point A to point B by no later than 10:30 a.m., and let's say some sort of uncontrollable event happened where the train couldn't get them to that destination by that time, one of our blockchain smart contracts is listening out for those changes in terms of delays, and actually emitting an event that will then do one of two things based on insurance pricing. It can give them a coupon to buy a coffee while they wait on the stand for their ride to come. Or the second thing is create an alternative route for that user to be able to get to their end destination in time. So for instance, if this train is going to be delayed, then okay, we calculate we have 15 more minutes to get where we need to go. Let's just rent the nearest car, and the user can walk up to that car, unlock it with our ticket, and drive themselves to their end destination so that they make it in time. And then of course, other success metrics were the ability for all the companies within the consortium to transparently and confidently view their users' transport history, trusting that no company tampered with any record for the sake of increasing their profits. As well as we wanted an easy way to onboard new consortium members, because as we can see, this is like a big project across Japan. But to begin with, we only had roughly 15 companies at the table. But that does not mean we want to exclude any other train companies. It's just a matter of inviting them to join the consortium as we move along and we build the consortium even further. So what we wanted was an easy way to do this, and ideally in a short setup as possible and no code. And then of course we wanted to exchange the Japanese yen to ERC20 tokens, and we wanted the customer to be able to buy tickets, to buy that one ticket that represented multiple services with the ERC20 tokens we are using in our ecosystem. So those were our success metrics, and this is what we were able to capture from our architectural design sessions. And we all digested and agreed upon this across all the companies before we started actually writing in detail what exactly we will be creating, and then of course implementing that. So this is a high level diagram. As you can see, this is a consortium where Mizuho was the bank, and the bank provided us the open API for us to exchange the yen to Japanese yen to the MAS token. And we decided to call our ERC20 token MAS token for mobility as a service. And then of course, all these other nodes alongside here is variations of taxi companies, train companies, bus companies, and any other transport mechanism in Japan. Then we had a representative of a ticket office. We had to document this as a smart contract. So in tradition, well, traditionally your ticket office is like that booth in the train station you go up to and buy stuff, but we needed to translate that business logic into smart contracts so that we can trust our blockchain ecosystem to handle the whole ticket office task of, okay, this user wants to get from point A to point B, so therefore we need to aggregate bus A, train B, and car C into one ticket, and what is that final cost, and therefore do the distribution across the companies once the user actually rides. So this was one smart contract we had to create to represent that ticket office. And then of course, this was all the external systems we use. We use like a business intelligence. We had a mobile app where the user will interact with our unified platform through this mobile app by using their decentralized identity that we were able to verify using their Japanese ID card and store that information in a decentralized identity hub. So we did that approach because we didn't want any company or any company within our consortium to have access to user identity and user login and all. Like, someone will have had to manage the traditional non-DID identity, right? And we needed a way to also verify this user is real. So that's why we use that Japanese ID card. And we trusted the decentralized web to store that and validate that for us. And pretty much the user comes into this app, logs in through their DID, and then what they do is pretty much enter their route. And in our backend system, we are able to calculate the exact ticket using the ticket office, then give them that ticket. Once that ticket is created, it goes back to the user. So as you can see on that user screen now has a ticket on it. And then when the user is ready to enter, let's say gate 1 of that train, all that user has to do is walk up to the gate. These are representatives of gates, the gate simulate. This is a gate simulator where you have to like tap to enter. So all that user has to walk up to do is scan. We did QR codes initially. So scan the QR code no matter who owns this specific company and be able to continue along their path. And of course, when all of these actions is being taken, we have records being stored, events being emitted, and then of course, all the compliance and auditing needs for each business is being captured. Then this is a more detailed walkthrough of what I just said. Like I mentioned, the shared ledger between all the companies is Quorum, hosted by Azure Blockchain Service. And then within this ledger has all that smart contract logic and is literally the representative state of truth, the source of truth in terms of what has occurred and what events has been emitted and what is exactly the state of each smart contract and so on. And this represents the user flow from, like, let's say a tourist perspective, where the tourists reach in the airport, downloads the app, which is the MAS app. They register using DID alongside their ID card, well, Japanese ID card. And once they're registered, we know for sure they are a proven user. And this is mainly important because of that bank exchange we need to do from like their yen to their ERC20 token, because we are using that ERC20 token to actually create the MAS ticket. And then from once that MAS ticket is created, we'll still need to use that ERC20 token to fracture the profit across all the companies within the system. So as I said, this user comes in, this user knows they want to get from airport to hotels, so they enter that route, and all of our logic in smart contracts and so forth is able to tap the ticket office, create the ticket that represents all of the stops that they need to do, And then let's say this user opt in for insurance, right? And they want inclusive insurance. They want the highest premium of insurance. So that means that they're paying so that if they run late, they're able to be redirected to a share car. And so this user has that ticket that represents all of the routes they have to take along with the insurance. So now the user can start along their way. So the user starts in the first stop or the first provider, which is a train. So they show the QR code to the gate. The gate approves the QR code because that company's external systems already was expecting that user based on whatever event is emitted in the blockchain. Then the user gets in because that code is valid and is able to make it to their point B. When they're in point B, they realize that the train is not working there. So then as efficiently, as quickly as possible, without the user having to tap anything, our events within our blockchain emits saying that this train is delayed, so we need to find an alternative route. The best alternative route to get this user to their hotel is to get them a keys for a share car. And when I say key, this is literally a digital key that's also part of this QR code. So by the time we update users saying, hey, this train is no longer working, you should walk 5 minutes to find this car and drive this car to your end destination. By the time the user makes it here, all the user has to do is scan their not their QR code. I believe we use NFC against the car door, and that will unlock the car. And then the user is able to drive to their final destination and make it to their hotel as expected, without any sort of understanding of the fact that there's 1,000 different companies involved in this end-to-end flow. So this was the solution we created. And feel free, so a big part of this solution was the IoT around like the gates. For instance, this QR code, we actually interacted with hardware. So therefore we had to like really think through like, how do we take high throughput data from the IoT devices, which is the gates in our situation, and really populate that to the blockchain? Because as we know, blockchain transactions take a while, could take a really long while to actually be stored in the blockchain. So I will speak on that further coming up. And I just included a couple of screenshots of our some of our smart contracts. So this smart contract you're seeing is our mass coin, where we pretty much build it ERC20 using the Open Zeppelin standard. And all this has to do is mint coins and send it to the sender. Then our mass ticket was represented as the ERC721 because the mass ticket doesn't necessarily have value, but is more business logic. And like I said, one of our success metrics is to have one ticket representing all the different route providers and routes that user has to take. So as you can see, we built it using ERC721 Open Zeppelin standard as well, where we had a couple of the functions that I display here, is like get ticket detail by ID, the actual minting of the ticket for the user, and like a function to access how much tokens or how much tickets, how much mass ticket a specific user owns and is still active. And then, of course, from a high-level view, this is the application flow. Like I mentioned, the user had a mobile app and a web app to enter. And then, of course, in the whole client and API paradigm, any action that user takes within the mobile app and web app will trigger API call and potentially blockchain events and smart contract functions and so forth. So this is the blockchain, this is the app, and in between we have our logic app and our Azure function sitting that is listening to a specific API call or event or so on. So let me just walk through one of these. Let's see, let's do the gate simulator. So let's say this user on their phone, on their app, has the QR code for their ticket open and they reach to the gate. Then the moment the user shows the gate the QR code, in our ecosystem, we have an API call for Gate Simulator, which then calls the logic app that is responsible for emitting the event in out station in the blockchain, so that all the company partners are aware of exactly when this user came into what station and when did they exit that station. And then, like I mentioned, the biggest bottleneck in this solution was that gateway, that gate simulator, because of how high frequency IoT data is, and just based on like the domain that we're working in, which is the transport industry. At any given time, there could be 1 million people entering and exiting a specific gate in Japan. So we had to be very strategic in terms of how exactly we wanted to write to the blockchain these events. And we created a flow where we leverage our IoT product in Azure to be able to capture the events, and then over a certain time interval, add it to an immutable blob, which is another feature of Azure that ensures that this blob or this data, let's say this file, cannot be touched, cannot be tampered. And therefore, once the interval has passed, with let's say every 1 minute we want to write whatever in and out of gateway events we receive to the blockchain, then we have this blob that is collecting all of those events within that 1 minute interval. And once the 1 minute is up, that's when we will hash that blob and anchor it on the blockchain. And then, of course, that means our end user isn't impacted by how long it takes for the blockchain to write and capture certain change in states. So therefore, the user can go on with their life, and we can also trust that while we are waiting for the event to be, the data to be captured on the blockchain, it's not being tampered with. And I actually can share the link to an open source variation of this for you to look into. And yeah, that's it. So I had another example, but I'll leave it in my slide for when you're able to view my slides. And let me just jump to the end. So overall, thank you for listening to my presentation. This is the GitHub repo for the open source solution of that IoT high frequency data I mentioned. And this is an article explaining the mobility as a service project we did in Japan for you to get more context if you're interested. And of course, you can find me on Twitter, Instagram at ImpactWith, and feel free to connect with me on LinkedIn as well. Thank you so much.